Okay, so Algebra 2, this is lesson 17, and part A is about subscripted variables. As your notes, sorry about that, I hit the wrong button. As your notes indicate, subscripted variables can be very helpful. It's good to use meaningful variables so that you know what the letters stand for. You could declare your variables, which you need to do when you're programming computers also, but then you'd have to actually write, let x equal, in this case, number of nickels. Let y equal, number of dimes. And then you can write your equation. And then whenever you get your solution, you'd have to go back and say, okay, so if x equals 10, then I write for my answer the number of nickels. 10 is a number of nickels. It's more helpful often to use these subscripted variables. They are meaningful. Number of nickels, number of dimes. And whenever you're using formulas, it's in science and business applications, there are certain formulas you have where you just need to have those subscripted variables. So this is our chance to practice with those. Also, this particular thing is getting you ready for a kind of problem we're going to be doing later. So, even though you see the big letter is the same here, the subscript is what's differentiating them, so these are not like terms. This is number of nickels, this is number of dimes. And then here is another equation. You see the brace, this is a system of equations. This is like the ones where we had the x and the y, and we need to solve for both. So we are still going to do that just like normal. We could substitute or eliminate. And I guess for this one, I will substitute, and then well, I'm going to have to substitute on the other one also, but this one does lend itself to that. Let's just do that. So how about we get n sub d, that's why I say that because it's a subscript, n sub d. We're going to get n sub d by itself. I'm just going to write this over here. Whoops, that's supposed to be a plus. N sub n plus n sub d equals 40. And if I want the number of dimes by itself, I'm subtracting n sub n. N sub d equals 40 minus n sub n. And then I can substitute that in place of n sub d in the second equation. So 5 times the number of nickels plus 10 times 40 minus the number of nickels equals 250. Make sure you take enough time to write this neatly so your subscripts look like subscripts. They should be lower. Okay, so we have that. Then we distribute this 10. 5 times the number of nickels plus 400 minus 10 times the number of nickels equals 250. I then add my like terms. They're opposite signs, so I subtract and keep the negative. And plus 400 equals 250. Now we subtract 400 because we need to get that variable by itself. Negative 5 times n sub n equals, okay, it looks like 150, but it's negative, right? 400 minus 250, but the larger is negative, so we keep the negative. Divide both sides by negative 5. And this is going to give us 30. The number of nickels will be 30. And for a problem like this, I know what this is standing for. I know I'm not going to have negatives, and I'm not going to have fractions, because it's nickels and dimes. So this is good. If I got a negative or I got a fraction for one of these particular types of problems, I would want to go back and find out what I did wrong. It's often a sign error. Okay, so now that we have the number of nickels, we go back to one of the equations, and I'm actually going to go to this one right here, where I already have the number of dimes by itself. The number of dimes is 40 minus the number of nickels. Well, I'm saying that's 30, so it's 40 minus 30. The number of dimes is 10. So, well, I just write, well, we didn't know it was a word problem. N sub n equals 30, n sub d equals 10. Done. These you don't have to write like an ordered pair. but that's it. All right, now in the back, okay, like it says, these are particularly useful. Again, when we're using formulas, this is just one of many formulas you'll be using just over the next several years. This is distance equals rate times time. So these are used for uniform motion problems. We'll be using these quite a bit. And this could be written in a more user-friendly way, I think, but this is how you'll see them in the book, and I want you to be prepared. So, solve this system of equations. This, okay, r sub m t sub m plus r sub w t sub w equals 260. And here is a semicolon. That is the end of that equation. That is your main equation, and the rest of this are things we're going to substitute into that equation. All right, so whenever you're doing these in the problem set, this is what you'll write on the top line in your box. And then underneath that, you'll start filling some things in. Now, this equation over here on the left does not have a does not have a variable by itself. So I need to get that rearranged before I can substitute. And it's entirely up to you whether you want t sub m or t sub w by itself. It really doesn't matter. I guess I'll get t sub w by itself. Okay, so t sub w would equal 5 minus t sub m. Now, I go back through this equation and put this stuff in place of everything except there'll be one variable remaining, and then we'll solve for that. So r sub m is 40. We're multiplying that times t sub m, and I don't have that by itself anywhere. That's the variable that stays. Okay, plus r sub w, that's 60, times t sub w. Well, I have that that's 5 minus t sub m. So in parentheses, 5 minus t sub m. Okay, and that equals 260. That's a lot nicer. Now we just solve that. So first thing will be to distribute. That's 60. 40 t sub m plus 300. Okay, minus 60 t sub m equals 260. We'll subtract 300. This is a little bit of a shortcut. I do need to add these like terms, but then my next step would be to subtract. So if I show that I'm subtracting, that's gone. I'm adding these like terms. They're opposite signs, so I actually subtract. And then over here, that is negative 40. If you have any questions about this, please be sure to ask me. Now we are, I always want you to ask me when you have questions. Dividing by the coefficient, t sub m, 40 divided by 20 is 2. They're the same sign, so it's a positive 2. Now, we also need to find out, they gave us what both of the r's equal, but neither of the t's. So now, if t sub m is 2, and t sub m plus t sub w is 5, I know the other one has to be 3. So t sub w equals 3, and that's that. All right, part B. I think we've done ones like this before. I'm not quite sure why this was a section, but we're going to go ahead and do this example. And we're solving for x and y. It's possible before you only had one variable to solve for. Anyway, we have here two parallel lines crossed by a transversal. We know that all of the angles that look acute are congruent to each other because they are corresponding angles, or like this one and that one are alternate exterior angles. Okay, but I do know that that one and that one equal each other, so I can write 5x minus 10y equals 50. Notice I am not writing degree symbols. The variables aren't angles, they're just numbers. Okay, so I have that, and now this one plus this one make a straight angle, So then I know that 7x minus 2y has to be 130 because I add it to 50 and I'm supposed to get 180. So 7x minus 2y equals 130. Now, I either need to substitute or eliminate in order to solve for x and y. And I did substitution on example 1. I'm going to do elimination on this one. I think I'd rather eliminate y, so I only have to multiply times one of the equations. Because if I take 5 times 2, I'm getting 10. Only thing is, I need it to be a positive 10 because the other one's negative. So I'll be multiplying everything in that second equation by negative 5. On everything on both sides. So that means I have negative 35x plus 10y equals negative, all right, 0, 15, 650. Okay? Now, below that, I'm going to write this first equation. Okay, I'm just going to copy it down here. 5x minus 10y equals 50. Okay, so those cancel. I have now negative 30x equals negative 600. Divide both sides by negative 30. If I made the other one, change the sign of the first equation, I wouldn't have so many negatives here. But that gives me x. Negative divided by a negative will be a positive. And I just reduce that. 60 divided by 3 is 20. So x is 20. And I still need to solve for y. So I take any of my original equations, put that 20 back in for the x. So I'll take the first one. 5 times 20 minus 10y equals 50. All right, this is 100 minus 10y. So I'll subtract 100. Negative 10y. Sorry, I think you couldn't see that for a little while. All right, so I got my x equals 20. I put that in place of the x in my top equation here. 100 minus 10y equals 50. Now, again, we're here getting that variable by itself. Subtract the 100 from both sides. Don't forget that negative. Negative 10y equals, these are opposite signs. So I subtract negative 50, divide by negative 10. So y equals, it's going to be a positive 5. So x is 20, y equals 5. Okay? If I put them together and circle it, that's very easy to find the entire answer. I'm also not writing this as an ordered pair. It's not like these are representing lines and we have a point of intersection. It's just telling what the x and the y equal. So that is the end. I think that wasn't too bad. I'll see you soon.